Algebra 2 students, welcome to your 8.6 notes. This is the first time we've done the flipped method, and it's because I am absent. I'm sure you won't mind. But welcome to class. We're going to work on our 8.6 notes today. And the first thing that I'm going to show you how to do is how to get rid of the denominator. Okay? So the multiplication property of equality says that if I multiply both sides of my equation by the same thing, I'm totally legal. So I'm going to just simply multiply both sides of my equation by 2. All right? When I do that, check out what happens. Those 2's cancel out, those 2's cancel out, and basically I'm left with 3 is equal to 3x. And then I just need to solve it. And as you can see, when I divide both sides by 3, x is equal to 1. All right, so in my second example, I went ahead and did a little bit of my work off camera there, but now you can see it. And so when I multiply this first term right here, my x's are going to cancel out. Come on, little laser pointer, work with me. And so then I'm going to end up with a 4 times 3 situation. And then when I multiply this second term right here, my 4's are going to cancel out, right? And so then I'm going to end up with an 8x. Okay? And then over here, when I multiply by 4x, these x's will cancel out, and then I end up with a 4 times 2. So what I really have is 12 plus 8x is equal to 4 times 2, which is 8. All right? And I can subtract both sides by 12, and I'll end up with an 8x is equal to a negative 4. And then if I divide both sides by 8, I end up with x is equal to a negative 1/2. Okay, for my third example, I did the similar deal where I'm getting some of my work out of the way off camera there, so that way we don't waste too much time. And what's going to happen with this first term when I multiply it out is my 5p is basically just going to cancel out, and I'm going to end up with a p minus 1. All right? And then on this second term, I'm going to have my p's cancel out. Okay, this p right here and this p cancel out. So then I have a 5 times negative 1, which would be negative 5. All right. On my right-hand side of my equation, my 5's cancel out, and I end up with a 2p. So, for those of you with your Bart Simpson humor, I just said I have 2p. So, I have a negative 1 and a negative 5 over here on the left-hand side of my equation. I can go ahead and combine like terms. So I'll have a p minus 6 over here, and I'll still have a 2p over here. I'm going to go ahead and in one swoop move stuff around. I'm going to have plus 6 and plus 6, and then I'm going to subtract 2p, and I'm going to subtract 2p. When I do all of that, I end up with a negative p is equal to 6. And after I divide both sides by negative 1, I end up with a p is equal to a negative 6. Okay, so on number 4, I'm actually going to multiply both sides of my equation by a 6x squared. All right? And when I do that, okay, I'm going to have my 6x squared on the right-hand side cancel out, but the reason that I chose 6x squared is because it's going to cause this 6x squared to cancel out, but it'll also still eliminate my denominator over here. All right? So, when I divide 6x squared by x, I'm going to multiply that by 1. I basically end up with a 6x for my first term. All right? And then when I multiply this 6x squared over here, what I end up with is 6x squared divided by 3x, which gives me a 2x multiplied by 2, and I end up with a 4x for that term. Let's see if I can make that look a little better. Okay? On my right-hand side, this cancels out with this, and I end up with a 1. I can go ahead and combine like terms at this stage, so I'll have a 10x is equal to 1, and then I can divide both sides by 10, and x is equal to the fraction of 1 over 10. Alright, so in example number 5, I'm going to multiply both sides of my equation by 2m. And when I do that, I'm going to have an m and an m cancel out over here, so I'll have a 2. Alright, and on this left-hand side, I'm going to distribute my 2m to there, and I'm going to distribute my 2m to there. When I do that on this very first term, my 2m cancels out, I end up with a 1 sitting there. Okay, when I do that on this right term here, I'll end up with a 2m. Okay, so now all I have to do is do a little bit of simplification. So if I subtract 1 from both sides, I'll have 1 is equal to 2m. And then I can divide both sides by 2. And I get m is equal to 1/2. And there you have it. Okay. So I'm going to go ahead and do this one. I did this 2 different ways. The first way that I did it, I ended up not being capable of showing you something called an extraneous solution. So I'm going to go ahead and multiply both sides of my equation by x times x squared minus 6x. Okay, so this entire piece here, all right, is what I'm multiplying both of these by. I'm distributing that entire thing by both of the stuff, or all of the stuff inside of there. So I'm rewriting this entire thing, and I kind of rewrote it off camera to save just a little bit of time there. So again, I've got a double parenthesis there, and that whole thing is going to be multiplied. So that's going to give me, on my right-hand side of my equation, a 5x. All right, and on my left-hand side of my equation, let's see, let's go ahead and talk about this with a laser pointer. This and this would cancel out. Okay, so I would end up with an x. And then when I distribute here, let's go to the laser pointer, my x and my x would cancel out. So then I would have a minus 2 times all of that stuff right there, x squared minus 6x. Now remember, anytime that I actually cancel stuff out of my denominator, and I'm going to end up canceling these guys out of my denominator, but I have to kind of look at that and say, okay, what would make that undefined? Okay, and that would be undefined at x is equal to 0. Okay, so we'll end up putting x cannot equal 0 right over here. X cannot equal 0. Okay, so we'll kind of think about that as we move along here, and later on we're going to see that kind of pop up here. So I've got x minus 2 times x squared, and then when I multiply negative 2 times negative 6x, I'm going to end up with a positive 12x, and that is equal to 5x. So I'm going to go ahead and combine some like terms here. I've got a couple of x's over here on the left-hand side of my equation that I can combine. So I'm going to end up with a negative 2x squared, okay, plus 13x is equal to 5x. And I can subtract that 5x from both sides of my equation, and I'll end up with a negative 2x squared plus 8x is equal to 0. Okay, and then I'm going to go ahead and factor this. I'm going to factor a negative 2 out of negative 2x actually out of this sucker, and I'm going to get let's see, that's going to give me an x minus 4 is equal. All right, and then I'm going to set up two possibilities to actually get to 0. I would have negative 2x is equal to 0. And then I would have x minus 4 is equal to 0. Okay? So I can divide both sides by a negative 2 here. And I would get x is equal to, well, 0. And folks, that can't happen. We discussed that right up here. That's one of our extraneous solutions, so that one cannot occur. And then we simply have x plus 4 that can occur. All right, and so folks, that's our answer. All right, for those of you who like to think that we never will use this in our life, here's a real-world application. We're going to figure out how fast the river's current is. And we're going to do that by this problem. A kayaker spends an afternoon paddling on a river. She travels 3 miles upstream and 3 miles downstream in a total of 4 hours. In still water, the kayaker can travel at an average speed of 2 miles per hour. Based on this information, what is the average speed of the river's current? Okay, so I'm going to multiply both sides of my equation by my common denominator. I have to have a common denominator in order to add fractions together. Okay, so 2 minus c and 2 plus c. That's a plus. That's a plus. All right, I'm going to multiply the same thing on the other side. When I do, I have 4 times all that junk, 2 plus c. All right, and then the left-hand side of my problem is going to look quite interesting. My 2c, my 2 minus c, is going to cancel out, so I'll have 3 times 2 plus c. And then I'll have 3 times 2 minus c. Sorry about my voice. I'm not really sure why it's going away. You guys can deal with it. All right. So I'm going to distribute. So I'm going to have 8 minus 4c. And then I'm still going to have this set of 2 plus c. On this side, I'm going to have 6 plus 3c. And I'm going to have 6 minus, or up, it's actually, yeah, it's going to be a minus. Let's see if Mr. Bear can get his algebra correct here. I'll have minus 3c. All right, so I've got some 3c's over there that are going to cancel out. My right-hand side of the equation is going to be equal to 12. All right, and then I am going to go ahead and use the distributive property over here. So I've got 8 times 2 plus c, and I'm going to have a negative 4c times that same junk in there. That's the distributive property. When I go ahead and do my distribution, I've got 16 plus 8c minus 8c plus, nope, it's not going to be plus, it's going to be a subtraction. I'm going to minus 4c squared. And all that's equal to 12. All right. I think I might be able to finish before my 15-minute YouTube violation. All right, I can cancel out these 8c's, and then I end up with a negative 4c squared plus 16 is equal to 12. If I subtract 16 from both sides, I have a negative 4c squared is equal to a negative 4. I can divide both sides by a negative 4, and I have a c squared is equal to 1. Well, if I take the square root of both sides, I would get that c is equal to plus or minus 1, and you're really not going to have a river current that is minus 1, and so, folks, our current of our river is 1 mile per hour. Folks, that concludes our notes for Algebra 2 8.6. Enjoy some of the music, and it is going to be a good life.